So now life gets ugly. I'm going to be using the notation from Forsyth and Ponce. It might not be the best notation, but it is a notation for dealing with coordinate transformations, which is what we're going to be doing. So the idea here is that superscripts are going to represent what coordinate frame you're in. So here I have some point P. And I've got the A coordinate frame. And the expression of the location of point P in the A coordinate frame can be thought of as a variety of ways. You can think of it as the location x, y, z in the A frame. But if you remember a little bit from your, I don't know, algebra, calculus, the right way of thinking about the vector that goes from the origin to P, that's this vector here, is it's got the I component of the amount x, the j component of the amount ya, and the k component of the amount za. So a vector is actually the sum of these three components, the I component, j component, k component, each scaled by the coefficients x in A, y in A, z in A. Suppose I want to express the location of point P, whose value I might know in coordinate frame A, but I'd like to know where it is in terms of coordinate frame B. Well, that's just a translation. And it's handled very simply by saying the location of P in B is just the location of P in A plus the location of the origin A expressed in the B frame. All right? And so that equation just gives us that new offset. And this OA in B, that's just a 3 vector. That's the offset of the origin of A in the B frame. I told you this was ugly, but we have to slog through it. The good news is, once again, homogeneous transformations, or I should say homogeneous coordinates, are going to come to our rescue, where translation can be expressed as a multiplication. So we've rewritten this top equation, P in B is equal to P in A plus OA in B, as this matrix transformation. A couple of things. First of all, that I, that's a 3 by 3 identity matrix. So this is, and since OA in B is a 3 by 1. This is a 4 by 4 matrix, which means that this vector down here, that's actually a 0 vector of length 3 transpose, so it's 3 zeros in a row. It's actually 0, 0, 0, and this is 1, 1, 1, 0, 0, 0, 0, 0. That's clear, isn't it? That's why we draw it this way, okay? And just to remind you, translation is commutative, okay? And you can actually show that in the matrix multiplication if you wanted.